Hello, grade 10s. In today's lesson, we're going to be looking at factorizing difference of two squares and trinomials. And let's get right into the lesson. Ra. So I'll be teaching you a very quick and easy strategy to dealing with difference of two squares question and trinomials. So before we get right into it, let's just start by a revision of perfect squares, right? Now, what do we know? What are perfect squares? So we say perfect squares. These are all the numbers that you can put in a square root and they give you a perfect number like that. No decimals, right? So the first example of perfect square that we have is 1. So if you take 1 and put it in a square root, it gives you 1. And then followed by 4. If you take 4 and you put it in a square root, you have 2. Then we have 9. You take 9, you put it in a square root, we have 3, right? And then we have 16. Take 16, put it in a square root, we have 4. And then 25, take 25, you put it in a square root, you have 5. And then you have 36. 36 in a square root is 6. And let's continue with the perfect squares. We also have 49. 49, put it in a square root, we have 7. And then we have 64. 64, put it in a square root, we have 8. And then we have 81. 81, put it in a square root, you have 9. And then we have 100. 100, you put it in a square root, you have 10. Then we have 121. 121 in a square root, we have 11. Then let's look lastly at 144. You have 12, right? So these are examples of perfect squares, right? As we can see. Now, why am I teaching you this? It's because your perfect squares, they have a strong hold on your difference of two squares, right? You will realize that every time when you are given difference of two squares, the numbers that you are given there are perfect squares. Let's look. For example, you have a squared minus 4, right? If we can observe this, we can see this is difference of two squares. The a here, we have two a's, right? And then the number that you'll be given here for the variable here, always the exponent of the variable will be an even number, right? So that you can open two brackets and distribute it equally so. So the number there is always an even number. So this is a and this is a, right? And then when you look at 4, this is 4, it's a perfect square. But also again, one thing that tells you that this is difference of two squares, the sign that they're gonna use here is minus, right? So it's a squared minus 4. Always when you have a minus sign there, you know this is difference of two squares, right? So what are we going to do with this 4 now? If we take this 4, since it is a perfect square, and we put it in a square root, what answer do we get? We get 2, right? So now dealing with difference of two squares, we distribute this 2, right, into the brackets. Now we know in order to have this minus sign here, let's revise this. We know that if we have a positive and a positive, that's a positive. A negative and a negative, it's also a positive. But a negative times a positive is a negative, or a positive times a negative is a negative. What can we get from this? We get that every time when we are multiplying signs that are the same, we get a positive, and every time we are multiplying signs that are not the same, we get a negative. So because the last term here is negative, how are we going to ensure that it is a negative for these numbers, right? So now we want to find out what signs should we put in each of these brackets so that we have our number here, the product, being negative 4. So we know for that we need signs that are different. So you can have a plus here and have a minus there. So if you say positive 2 times negative 2, that's negative 4. But if you say plus 2 minus 2, you have 0. hence we don't have a middle term, right? So difference of two squares do not have a middle term. Now, what can we say about difference of two squares? We have deduced that they have no middle term. Most of the time, the last term is a perfect square. And then we can also see that the exponents are even. Right. Now let's look at other examples. We can also add, before we move, we can also add that there is a minus sign in between terms. So no middle term, last term is a perfect square, exponents are even, and there is a minus sign in between terms. Now let's look at other examples. Let's say this time we have y squared minus 81. Now how do we deal with this one? You open two brackets. Now since you have y squared, you need to distribute the y squared equally so you have y here and you have y here. Now we have the last term 81 and we can see that it is a perfect square. When we take 81 and put it in a square root, what do we get? We get 9, right? Meaning that this side we have 9 and also that side we have 9. Now because this is difference of two squares, they have opposite signs inside the bracket. Let's say we have plus and we have minus here. So 9 times negative 9, that's negative 81. But 9 minus 9, that's 0. No middle term. Now let's look at this one. Let's say now we are given x squared minus 1. Now again here you want to open two brackets and you want to distribute a variable equally so. This is x and that's x. But 1 is a perfect square. If you put 1 in a square root, you have 1, right? Meaning that we want to have 1 this side and 1 that side. What about the signs? Difference of two squares, we have different signs inside the brackets. And that's your solution. Let's see another one. Let's say this time around we have a to the power of 4 minus 100. Now we can see that the exponent that we have here is no longer 2, but it is still an even number. That means we can distribute it evenly. So we have a to the power of 2, a to the power of 2. Right. Now we know if these two multiply, we still want to have a to the power 4 because multiplying same basis, we add the exponents. Now let's look at our 100. 100 is a perfect square. If we put it in a square root, what answer do we have? It's 10. Now we distribute the 10 this side and 10 that side. Now our signs, let's have a positive here and negative there. Now always note that it is not compulsory that you must have a positive here and a negative there. You can have it also this way. A squared minus 10 and then a squared plus 10. This is still the same thing. Now let's have a look at this one. 4x squared minus 1. You can see that with the previous questions that we did, the variable here always had a coefficient of 1. But what if the coefficient is no longer 1? How do we solve this? Now, you can see that the coefficient is also a perfect square. So we take this 4 put it in a square root. Now we have 2. When we open 2 brackets, this is how we're going to distribute now. We have 2x, and on the other side we have 2x. So when you multiply this 2x times 2x, they give you 4x squared. Now also we're going to check our last term, it's 1. So 1 is a perfect square, that gives us 1. So we have 1 here and 1 that side. Plus and minus. And that's how you solve that one. Let's look at a similar one. Let's say this time we have 9x squared minus 16. Now the coefficient of the first term here is a perfect square. So we take 9, put it in a square root, and we have 3. Also 16 is a perfect square. So we say 16, square root of 16, we have 4. Now this is how we're going to distribute now. We have 3x, open another bracket, we have 3x. Then for this 16, we have 4 and 4. Now our signs, we can have a minus here, we can have a positive there. Nice one. Now that's it for difference of two squares. Let's now look at trinomials. Now you will note that trinomials always have 3 terms. And the terms are separated. Terms are separated by a plus or minus sign. Right. So the 3 terms and the terms are separated by a plus or minus sign. Let's have an example of a trinomial. This is x squared minus 4x plus 4. So we have our first term here. This is our second term separated by a minus sign. And this is our third term separated by a positive sign. And that's a trinomial. Now let's try to solve a trinomial. We have x squared minus 4x plus 4. Now how do we solve trinomials? We look at the last term, right? And now we're going to try to come up with the factors of the last term. So this is 4. What are factors of 4? That's 1, 2, and 4. Remember, we said factors are numbers that can go into a particular number and leave no remainder. So 1 can go to 4 and leave no remainder. 2 can go to 4 and leave no remainder. 4 can go into 4 and leave no remainder. Now you want to do the same thing that you did with difference of two squares, which is distribute this first term even. So we have x and x. But now to deal with this, we have to check the factors of 4 and say we want 2 factors of 4. When you multiply them, they give you the last term. When you add or subtract them, they will give you the middle term. Again, 2 factors of the last term of 4. When you multiply them, they will give you the last term. But when you add or subtract them, they give you the middle term. You can repeat the factors. So you have 2. If you put 2 here and you put 2 here, we can all agree that 2 times 2 is 4. And also if you add 2 and 2, it gives you 4. But now the 4 here is negative. Now if we revise the fact that we said that positive times positive is positive, negative times negative is positive, and negative times positive is negative. Now you will see that in order to have this positive, we can either have a positive sign and a positive sign, right? But if we put positive and positive here, yes, we're gonna have positive 4 when we multiply, but what about when we add? We have positive 4 and not negative 4. That means the signs that we need to have here is minus and minus. So we are guided by the middle term as to what signs we should put in there. But negative 2 times negative 2 is positive 4. And negative 2 plus negative 2 will give us negative 4. Right. Now let's say this time we have x squared plus 6x plus 9. Right. So for this one, again, we will distribute the x evenly so, and then we look at the last term, 9. What are the factors of 9? It's 1, 3, and 9. These are all the numbers that can go into 9 and leave no remainder. Now, what are 2 factors of 9? When you multiply them, they're going to give you 9, but when you add or subtract them, they give you 6. So we can all agree that it's 3 and 3. So what about the signs now? Remember, we are guided by the middle term. The middle term is positive and the last term is positive. So that means that's positive and positive. 3 multiplied by 3 is positive 9, and 3 plus 3 is positive 6. Now let's say this time we have a squared minus 8a plus 16. Now for this one again, open 2 brackets, distribute your variable a and a. Now we are looking at 16. Factors of 16 are 1, 2, 4, 8, and 16 itself. Now we want 2 factors of 16. When you multiply them, they're going to give you 16. When you add or subtract them, they give you 8. So we can all agree it's 4 and 4. And what about the signs? We are now guided by the second term, right? So we know we ought to have minus and minus. So negative 4 times negative 4 is positive 16. But negative 4 minus 4, it's negative 8. Now, what about a question like this? 9x squared minus 6x plus 1. Now we can see that the coefficient of the first term is no longer 1. So again, we refer to the same way we've been doing with difference of 2 squares. 9 is a perfect square. So that means we take this 9, put it in a square root, and we have 3. So opening 2 brackets like this, now we have 3x, and that side we have 3x. Right. But now we are looking at the last term. The last term only has one factor, which is 1 and 1. So we have 1 here and 1 there. So the signs, we are guided by the second term. We need to have negative 1 and negative 1. So if we say 3 times 3, 3x times 3x, that's 9x squared. But 3x times negative 1, it's negative 3x. And also 1 times negative 3x is negative 3x. When you add the two, negative 3x and another negative 3x, you have negative 6x. Let's try that one with this. Now we have 25x squared plus 20x plus 4. So the 25 here is a perfect square. So we say 25 is equals to 5. Square root of 25 is 5. Then distribute, we have 5x. And then also that side we have 5x. Now what are the factors of 4? For 4 we have 1, 2, and 4. Now what are two factors of 4 that will give you 4 when you multiply them? So that can either be 4 times 1 or 2 times 2. But now remember, you also need to have this 20x from that. So if we say 2 and 2, we understand that 5 times 2 is 10, and also 2 times 5 is 10. So that's going to give us 20, right? So 5 multiplied by 2, that's 10, and 2 multiplied by 5, that's 10. So 10 and 10 gives you 20x. Now we can see the signs that we have here. That's a positive, and also in the last term it's a positive. So the signs that we should have is plus and plus. Now let's have a look at the last one. We have 36 minus 12x plus x squared. Now with this one, the first thing that you want to do is you want to write it in a standard form, the way we are used to it. So whereby we start with the variable that has the highest degree or the largest value of the exponent. So we have x squared followed by minus 12x, then plus 36. Now we want to distribute this equally so. So we have x and x. Now we are looking at the factors of 36. We have 1, 2, 3, and then we have 4, we have 6, we have is it 12, and then lastly, we also have 18, and then we have 86, right? So for this one, we say two factors of 36, when you multiply them, they're gonna give you 36, and when you add or subtract them, they're gonna give you 12. So that's obviously 6 and 6. And the signs, we are guided by the second term, so we need to have minus here and minus there. So negative 6 times negative 6, that's 36, but negative 6 minus 6, that's negative 12.